Next, let's go for numerical questions here. So 21st question, what is given? In a GP, if the product of the first three terms is 27, and the set of all possible values for the sum of first three terms is R minus of A to D, then A square plus B square is equals to, right? So it's a simple GP question. So what is given here? Product of first three terms is 27, right? So whenever a GP is given and if they are asking for first three terms means you can assume like this: A by R, A, AR. So always whenever three terms are there, you can assume the GP as like this because it is easy for calculations. Now it is given that product of first three terms is 27. If you product the three terms here, so you will be getting A by R into A into AR equals to 27. So RR will cancel out. So A cube equals to 27, which gives A is equals to 3. Right? Now they are asking for set of all possible values for sum of the first three terms. Now let us say sum is A by R plus A plus AR. Right? Now, so if I take out A common here, I will get R plus 1 by R plus 1, right? A is 3 here. So R plus 1 by R plus 1, right? So here we need to find the possible values of this particular expression. Now it's clearly R plus 1 by R is there. We already know that if X plus 1 by X is there, X plus 1 by X is always between minus infinity to minus 2 union 2 to infinity. You need to remember this, right? So here I can do the same thing here. But here they're asking for 3 into r plus 1 by r plus 1, right? So what I can say is r plus 1 by r is like this. So r plus 1 by r plus 1 means minus infinity to minus 1 union 3 to infinity. We can add up 1 here and you have to multiply with 3. So if I multiply with 3, I will get minus infinity to minus 3 union 9 to infinity, right? So I can write this one as r minus minus 3 to 9. So it is given as r minus a to b. So a is minus 3, B is 9. On comparing the expression, we get A is minus 3, B is 9. They were asking for A square plus B square. Very simple question. A square plus B square means 9 plus 81, which is 90. So the answer is 90 for this. See the 22nd question. 22nd question, what is given here? For some theta belongs to 0 to pi by 2. Eccentricity and length of lattice rectum of hyperbola is even L1. And let eccentricity and length of lattice rectum of ellipse is E to L2, and one condition is given and they are asking for this expression value, right? So it's a geometric question. So let's write the data what is given here. So first one, hyperbola is given x square minus y square secant square theta equals to 8. So can I write this one like this? X square by 8 minus y square by 8 cos square theta equals to 1. Now I can write the eccentricity like this: 1 plus b square by a square, right? Eccentricity of hyperbola. Now 1 plus 8 cos square theta by 8. So you are getting 1 plus cos square theta. So E1 square is 1 plus cos square theta. So here relation between E1 square and E2 square is given. Let's find E2 square also. So here hyper ellipse you can consider here x square plus what is given x square secant square theta plus y square equals to 6, right? So this is ellipse. So x square by 6 cos square theta plus y square by 6 equals to 1. So it's clearly vertical ellipse. How can we say vertical ellipse? It's not horizontal ellipse because here a square is less than b square because 6 cos square theta is obviously less than 6, right? So now I can calculate E2 square as 1 minus b square by a square. In here, b square means you need to write 6 cos square theta, not 6. right? Because it's a vertical ellipse, so I can write this one as sine square theta. So E2 square is sine square theta. Now the given condition is like this. So take this condition. So E1 square means what is given? 1 plus cos square theta. Substitute here. 1 plus cos square theta. E2 square means sine square theta. 1 plus secant square theta means 1 plus cos square theta by cos square theta, right? So we can write 1 by cos square theta, right? If we take the LCM, you get this expression. So this expression cancels out. Tan square theta equals to 1, which will give tan theta is plus or minus 1. So here theta range is also given. Theta is between 0 to pi by 2. So definitely theta must be, tan theta must be positive and theta must be pi by 4. Now, what is the question they were asking? They were asking for this expression L1 L2 by E1 into tan square theta. Already tan square theta is evaluated, that is 1. You need to calculate L1 L2. E1 E2 also evaluated. So let's calculate L1 L2. So for this one, L1 means length of lattice vector here. So for this one, L1 is 2b square by E. So here 2b square means 2 into 8 cos square theta by root 8. So you are getting 2 root 8 cos square theta. Anyways, cos theta, theta we got pi by 4. So substitute here. So L1 we are getting 2 root 8 into 1 by 2. So L1 is root 8. Okay. Similarly, L2 calculate here. We can calculate L2 is 2b square by again the same formula. But here you have to write 6 cos square theta. Sorry, 2b square, right? Yeah, 6 cos square theta by, yeah, root 6. So 2 root 6 cos square theta. So which you will be getting as root 6 because cos square theta means 1 by 2. So root 6. L2 is root 6. And E1, E2 also we can calculate. E1 square is 1 plus 1 by 2. So which is 3 by 2. It is E1 square. E2 square is 1 by 2. Now substitute in the equation, we get L1 L2 by E1 E2. So root 6 root 8. Root 6 into root 8 by E1 E2. E1 means root 3 by root of 3 by 2 and root of 1 by 2, right? Into tan square theta. Tan square theta is 1. Now we have to calculate this. So root of 6 into 8 by 3 by 4. So this is 2 times, right? So you'll be getting 8 square. This is 8. So the answer must be 8. So here the answer is 8. Done. Let's move to the next question. Yeah, 23rd question here. So what is given? K is given as tan of pi by 4 plus half cos inverse 2 by 3, tan of 1 by 2 of sine inverse 2 by 3. The number of solutions of the equation, right? Here in this equation, K is there. K is given here. So, but K you have to evaluate from here. So what can we do? So first of all, take the question like this. So let's evaluate K here. So tan of pi by 4 plus half cos inverse 2 by 3 is given. But here half sine inverse is there. So here cos inverse and here sine inverse. So what I will do is I will convert everything in terms of cos inverse. So because we know the relation, we already know the relation between sine inverse x and cos inverse x. We can use the relation to convert everything in terms of sine inverse or cos inverse, right? Is equals to 1. So I will convert sine inverse x, sorry, is equals to pi by 2. So sine inverse x equals to pi by 2 minus cos inverse x, right? So substitute over here. So you'll be getting k is equals to tan of pi by 4 plus half cos inverse 2 by 3 plus tan of half of pi by 2 minus cos inverse 2 by 3. So what I will do is I will take half cos inverse 2 by 3 as some theta. I will substitute like this. Now I can write k is equals to tan of pi by 4 plus theta plus tan of half of this one means pi by 4 minus half of cos inverse 2 by 3, right? So I get pi by 4 minus theta. So we already know the formula for these two. So just expand it 1 plus tan theta by 1 minus tan theta plus 1 minus tan theta by 1 plus tan theta. So take the cross multiplication, we'll get 2 times of 1 plus tan square theta by 1 minus tan square theta. Now, seeing this 1 minus tan square theta by 1 plus tan square theta means cos 2 theta. So what I will do is I can write 2 by cos 2 theta, right? Because cos 2 theta is 1 minus tan square theta by 1 plus tan square theta, right? So here we are already taken half cos inverse 2 by 3, cos inverse 2 by 3 as theta. So what I write is cos inverse 2 by 3 is 2 theta. So I can say cos 2 theta is 2 by 3. Just substitute over here. So I will be getting 2 by 3. So I'm getting 3. So which is the value of k? So therefore k value is 3. Now, so after k finding k value, we need to solve this equation, right? So what is given here? Sine inverse of kx minus 1. So if you put k is equal to 3, I get sine inverse of 3x minus 1 equals to sine inverse x minus cos inverse x. Okay. So I will convert again this one in terms of sine inverse of x minus of pi by 2 minus sine inverse x. So which is 2 sine inverse x minus pi by 2. So whenever these kind of inverse trigonometric equations are there, if it is sine in terms of sine inverse, then apply sine on both sides. Okay. If it is in terms of cos inverse, apply cos. If it is tan inverse, apply tan. Right. So what we can do is we can directly apply sine. So what I mean is sine inverse. I'm explaining a technique here. Just apply that sine, and I will let you know how to check this one. Right. Sine of 2 sine inverse x minus pi by 2. Okay. Right. So here I am getting, you can directly write here it is 3x minus 1 equals to sine. So if you apply sine of, I can write minus of sine of pi by 2 minus 2 sine inverse x. I can take minus common here. So pi by 2 minus means minus cos of 2 sine inverse x. Now you need to simplify this. So how can we simplify this? So let 2 sine inverse x equals to theta, or else sine inverse x equals to theta. You can take let sine inverse x equals to theta, which means sine theta is x. So if you put this, you get minus cos 2 theta. But we need we know already sine theta. So what I will do is I will write this one as 1 minus 2 sine square theta. So just I will substitute what is sine theta minus 2 x square. So taking this to this side, you will get 3x equals to minus 1 cancels out. You will be getting 2x squared. So either x equals to 0 or x equals to 3 by 2. So to solve inverse trigonometric equations, if sine inverse is given, you can apply sine on both sides. If cos inverse is given, you can apply cos, or tan inverse is given, you can apply tan. But after applying, you will get you will get the solutions. What you need to do is whatever the solutions we are getting need not be the final solutions. So you need to verify whether they are correct solutions or not just by substituting in the original equation. Okay, if you substitute 0 here, so if you substitute 0 here, you are getting sine inverse minus 1. That means minus pi by 2. Sine inverse 0 is 0. So minus pi by 2 equals to minus pi by 2. You get the answer, right? So similarly, here sine inverse x is there, so x must should not be greater than 3, greater than 1. So it cannot take 3 by 2. So it is not a valid solution, but only x equals to 0 is the valid solution. So the number of solutions, the question is the number of solutions of the equation. So the answer is 1, right? Yeah. So the answer is 1 for this. Next, let's move to the next question. Now the question is like this. It is given that sigma r is running from 1 to 20 and box of modulus of square root of pi times of 0 to r x into mod of sine of pi x dx, right? So here in this question it is a simple definite integration, but you can see square root is given, modulus is also given. Okay, so by seeing the square root and modulus, you don't need to bother. So just you need to solve it step by step. So how can we solve it? So let's see here. I'm taking the inside integration value. So 0 to r x into mod of sine of pi x dx. So now let us analyze how this sigma is going to work, right? If I put r equals to 1, I will get this one as like this. So if I apply sigma for this, so I will get 0 to 1 x mod of sine pi x dx. And if I keep r equals to 2, I will get 0 to 2 x mod of sine pi x dx, right? You understand, right, how the sigma is going to work. So in this square root itself, you are going to have summation of these terms. It goes up to 20, right? So let us solve step by step. So what I will do is, I will solve the first term when r is 1, right? So now 0 to 1 x sine of pi x modulus of sine of pi x dx, right? So as it is modulus is given, so whenever modulus is given, always try to remove the modulus, then solve the question. So now here, if x is between 0 to 1, that means this inside the argument is between 0 to pi. In 0 to pi, sign is positive. Just you need to, as it is positive, you can take off the modulus. So I can write this one as x into sine pi x dx. So these are two dissimilar functions. I'm taking this as first function, this is second function. By using Eilert rule, we can decide the first and second function, right? So integrate it by using by parts. So x into minus cos of pi x by pi minus of minus cos pi x by pi, differentiation of this one into 1 dx. So what you're going to get is minus x cos pi x by pi. Finally, the integration is like this, plus sine pi x by pi square. Now, the same integration will be coming in the other terms also, but only thing is the limits will change. If I take r equals to 1, it will be 0 to 1. If I take r equals to 2, it is 0 to 2, like that. So just remember, write this integration, and I am applying 1 to 0 now for the first term, right? If I apply 1 here, minus of 1 means 1 into cos pi, minus 1 by pi, 0 means 0, plus if I substitute 1 here, sin pi 0, substitute 0, cos 0, 0. So I'm getting 1 by pi. The first term is 1 by pi. Now if apply here, it is multiplied with pi. So pi into 1 by pi means I'm getting 1. The first term is 1. So our T1 is 1. Okay. Next, if I take r equals to 2, second term I'm considering, so I will get 0 to 2. The same integration, x mod sine pi x dx. So, but all I need to do is, so 0 to 1, it is clearly positive, right? Because this inside value is between 0 to pi, right? But 1 to 2, it is negative. So, what I will do is I will apply minus here. So, minus of x sine by x dx. So we have already evaluated this. So this is 1 by pi minus of let's apply limits for this integration is already evaluated. We have to apply 2 to 1, right? So I am considering the same thing here. So now the limits are 2 to 1. Okay. So if I am applying the limits 2 to 1, so 2 if I apply minus of 2 into cos 2 pi means 1, 2 by pi, minus of 1 if I apply minus 1, minus 1, that means 1 plus 1 by pi, right? If I apply this for this one, sine 2 pi means, so 2 pi means 0, cos pi is also 0, so that is 0. So you are getting minus 3 by pi for this term. So here it is minus of is given. So plus 3 by pi you will be getting. So the answer would be 4 by pi. The second term is 4 by pi. Now you need to multiply with pi and you have to take square root. Now our second term. So T1 we got 1. T2 we are getting 2. Square root of 4, 2. Right? Similarly, we can see the third term also. So if you put r equals to 3, you are just going to get 0 to 1 x 0 to 3 x mod sine pi x dx. That means already we have 0 to 2 x mod sine pi x. Then again you need to write 2 to 3 x mod sine pi x dx. So the cycle gets repeated. Here already we have got this as 4 by pi, right? Now this value is 4 by pi. Now we can see this value as in 2 to 3 means 2 pi to 3 pi is positive. Integration, the same thing, same integration, we need to apply 2 to 3 values, right? So that means here I'm taking this and I'm applying the limits 3, 2. So if I apply 3 minus 3 by pi I'm getting, and 2 minus 2 by pi I'm getting, and this is as usual, this is 0, so you are getting 5 by pi, so plus 5 by. Now we are getting the pattern clearly, 9 by pi, and it is multiplied with pi and taken square root 3. So clearly T3 is 3. So therefore the required integration or summation, required sum, you will be getting as 1 plus 2 plus 3 plus and so on, up to sigma is running from 1 to 20. So up to 20 terms you will be having this. So summation of first 20 natural numbers. So you can get the pattern and you can write like this. So the answer is n into n plus 1 by 2. So it is 210. So answer for this is 210. Right? Done. Let's move to the last question of the paper. Now here, what is given? Let PQR be a triangle such that PQ bar is given, PR bar is given, A comma B belongs to integers. Let S be the point on QR which is equidistant from the lines PQ and PR. If PR bar is 9, PS bar is this, then the value of 3A minus 4B, right? So it's a vector algebra question. So first of all, even if it is geometry or vector algebra, first we need to draw a rough sketch. So triangle PQR is there. So it is PQR. PQ bar is given as minus 2, minus 1, 2. PR bar is given as AB minus 4. Right? Now, S be a point on QR such that it is equidistant from PQ as well as PR. That means, can I say it is the definition of angular bisector? So that means S must be lying on the angular bisector, because what is the definition of angular bisector? The locus of the point which is equidistant from two given lines. So then it lies on angular bisector, right? So if it is the angular bisector, so clear the triangle PQR, PS is the internal angular bisector. Now what I do is I will assume origin is at P. Now, as PQ bar is this vector, I can take the position vector of Q as minus 2, minus 1, 2. Similarly, I can take position vector of this one as A comma B comma minus 4. Right? Now, uh, so here this magnitude PQ bar magnitude is root of 4 plus 1 plus 4, which is root 9, 3. The magnitude of this one is 3, and magnitude of PR bar is given as 9. Clearly, we know that if in a triangle ABC, if AD is the angular bisector, AD is the angular bisector, then BD by BC is equals to AB by AC, right? That means the angular bisector divides the opposite side in the ratio of corresponding sides. That means AB is to AC, right? You need to remember this very important result, right? I'm going to apply this result over here, right? And PS bar is also given, which is I cap minus 7j cap plus 2k cap. As P is origin, I can write this one as 1 minus 7 2. Okay. So now I can find the ratio in which S divides QR, right? That is nothing but 3 is to 9. That means 1 is to 3. So we know the ratio, we know the coordinates. So just relate them. So what we can do is 1 into A, 1 into A plus 3 into minus 2, that means minus 6 by 1 plus 3, 4, right, equals to 1. Similarly, 1 into B, next 3 into minus 1, my B minus 3 by 4 equals to minus 7. Similarly, 1 into minus 4 plus B into 3 into 2, 6 by 4 should be equals to 2. Here, what happens is, here if you equate these two, so I am getting A is equals to 10. Here I am getting B is equals to minus 28 plus 3. B is equals to minus 25. But the thing is, here the values are not matching up here. So you are getting 2 by 4 equals to 1 by 2, right? So there is some mistake in the question here. So that's why they had given you this question as drop. You can verify the final answer sheet. So it is given drop.